Embedded systems are devices that have an integrated CPU and RAM, which can process information internally without the need for a controlling system. The embedded device is the evolution of the terminal that really had very little or no brain power, very little or no CPU power. And there's so many embedded systems out there, you could lump just about everything that is an individual device with a CPU into the realm of the embedded system. They're found everywhere. Home appliances, for example, washing machines, your DVD player, dishwashers, your set-top box for your TV, your security system at home, office automation, an all-in-one multifunction printer or fax machine or a copy machine. Thin client computers. A thin client computer can be considered an embedded system. And we're talking about one that takes the place of a PC, has an embedded operating system. It's got a CPU, it's got RAM, it's got that network connection and display and USB connections for keyboard and mouse. And the whole thing with that embedded system is all the devices, the CPU and RAM, they're all embedded on one card, and the operating system is embedded. We used to have Windows embedded, CE, and we have other operating systems that could be embedded into memory. You've also got security systems, for example, biometrics or alarm systems. You've got telecommunications. Really, I mean, the Internet of Things, your routers, your switches, your cell phones, your smartphones, even your tablet computers, they could all be considered embedded systems. You'll find them in automotive. For example, GPS or cruise control on in your car, or your airbag system, or your ABS for brakes, or your fuel injection controller. There's all kinds of stuff. The more complex the car gets, the more expensive and luxury the car gets, the more embedded systems it may have, or the more complex the embedded system. You'll find it in medical, EEG, ECG, different diagnostics, blood pressure monitors, scanners. You'll find it in assembly systems. You'll find embedded systems in assembly lines where they're building things and possibly there's robotics involved. Or perhaps you're developing printed circuit boards or PCBs and there's some type of controlling system for that. It could just be something that'll run a program stating how those PCBs have the copper wires printed onto them, so to speak. Many more applications. Embedded systems can be found everywhere. But again, that idea is that you have the integrated CPU and RAM, and it can process information internally from an operating system that is embedded in memory without the need for an external controlling system. That's not to say that there won't be one, because in many cases there will be. So one example of an environment where you'll find embedded systems is going to be HVAC. That's heating, ventilation, and air conditioning at home or in the company. And here's an example. We have the Nest thermostat. And this is something that you would control from your mobile device wirelessly, but this will then in turn control your air conditioning and your heat. So this is a very basic example. If you get into larger buildings, you're going to need something more powerful, something like this that might mount to the wall with a QVGA screen, an ARM-based CPU. Traditionally, the typical embedded system is associated with RISC processors from the very beginning. And so with these types of systems nowadays, you'll see an ARM CPU, an ARM-based CPU, and various connections available. Serial connections, the old school serial connections, Ethernet connections, and USB, as well as wireless sometimes. But that can be a security risk. The bigger the environment that you're trying to control, the less often you'll find wireless. Then you have SCADA systems, SCADA. Some people pronounce it SCADA or SCADA. Supervisory control and data acquisition system. This takes it to the next level. You have much larger infrastructures that you're trying to control. For example, electrical power grids, water treatment plants, gas and oil pipelines, hydroelectric systems, sewage systems, traffic systems, building controls, dock systems, and on and on and on. Now here we'll have multiple embedded systems and at least one controlling computer, and often special software to control that. And here's an example. Siemens is a big player when it comes to SCADA systems and other industrial control systems. And you can see here it's going to come with software that's run on a PC or a server. And then you have devices which may be mounted to a wall or may be rack mounted. And the whole thing is controlled from a workstation by an administrator. And this is an up-and-coming field for the electronics/electrical engineer that can harness the power and knowledge of hardware, actual systems, and programming within C language quite often. So this is a big field, up and coming, but there's a lot of security issues with this. I mentioned wireless can be an issue. Just access to these devices can be an issue in general. So security is huge because they're used in the infrastructure of your country, electrical power grids, nuclear systems, water systems, really everything that keeps our society going. So it has to be secured effectively. So you'll have engineers that program these and install them, and then you'll have engineers that secure them as well. So those are two examples of embedded environments, HVAC and SCADA systems. You also have legacy devices. The A+ exams might ask you about legacy devices. These are older embedded systems, and some examples: the old school PC-104 computer, which ran between 25 and 33 megahertz. Very basic single board with a very simple CPU and RAM. Also DAQ controllers, older thin clients as well. Give a couple quick examples of those. Here are some single board PC-104 embedded computers. And, the reason they still sell these is because your company's HVAC or whatever system they're running might use a box that controls these things. And the boards can go bad over time. It could be because of condensation, or it could be because of the environment's very dirty and dusty, or chips just fail over time. So they sell boards that you can replace inside the box. And you can see here, 33 megahertz, 16 megabytes of RAM, 1 megabyte flash onboard storage. And then your interfaces, the PC-104 interface, 2 COM ports, an RS-485, that's a serial port. So you have this basic legacy board. But again, if you're going to be using a more advanced industrial control system, you may want to phase these guys out. Here's a multiple serial port box, which can control a lot of those old devices. You can connect them all to this box, and then you have connectivity through the Ethernet or USB so that you can control it from a newer system. But again, there could be a security risk with that if you are using older boxes. So you got to be careful with the legacy devices. And you'll notice down here that this is part of the ROHS initiative, RoHS initiative, which is the lead-free initiative. That's a big deal in manufacturing and has been for 10, 15 years. You want to make sure that everything is lead-free, especially the boards. Any boards that you buy, you want to make sure that there is no lead in the manufacturing process, in the PCB process. And then here's an older thin client. This one isn't too old, but you can see some of the telltale signs of an older thin client that a company might have used as a replacement for a PC. You can see an LPT port. That's a parallel 25 pin. You can see your serial COM ports. You can see PS2, which actually have made a comeback on some PCs as a combo port, keyboard and mouse in one. But you'll see a lot of these ports here. Those are the legacy ports. The older legacy thin clients also have security issues, but the main problem with them is they're usually not fast enough to run the embedded operating systems that are required for today. So that's a little bit about embedded systems. Again, really anything can be considered an embedded system that has CPU and RAM, which can process information with an embedded operating system of some sort. It could be basic Linux. It could be, something that you wrote yourself from Windows C. It could be Android. It could be iOS. But the idea is it's a single device. But traditionally, the embedded system is something that deals with industrial HVAC systems, or supervisory control and data acquisition systems in larger infrastructures. So that's a little bit about embedded systems. So you want to know just the basics about that, and also your internet appliances for the exams, your firewalls, your IDS and IPS and your UTM solutions, and the different types of servers that are out there and the server roles that you might encounter. And I'll see you at the next lesson.